All right, this is Mr. McCord's ICP class, Unit 4, Assignment number 4, Periodic Table Classification. We want to be able to pick out an element from the periodic table and get some information about it. We've already talked about things like the atomic number, which tells us the number of protons and the matching number of total electrons. We talked about the number of neutrons based on the mass number of a specific isotope, where we have a little dash and a number. That's the protons plus neutrons, or an atomic symbol, where we've got a little top left number that has the same thing, protons plus neutrons. We just subtract out protons for that element to get the number of neutrons. And we also talked about the number of valence electrons. So everything in this first column has one valence electron. Everything in the second column has two valence electrons, and so on and so forth. Red here. We kind of skip this middle section, and then column 13 stuff has 3 valence electrons. Column 14 stuff has 4 valence electrons. Column 15 has 5 valence electrons. Column 16 has 6 valence electrons. 17 has 7. 18 has 8. All except helium, which has 2 valence electrons, just because it doesn't have enough total electrons to reach that 8. But there are other things we can figure out about an element, how it is physically in our world, just based on where stuff is. So, first off, sectioned off in red here. It's kind of hard to tell, but sectioned off in red around here are our metals. It makes up a bulk periodic table. Some of these you'll recognize from nutrition labels, like potassium and calcium, sodium, and things like that. Others you'll recognize from physically dealing with metals, like copper or nickel or iron, silver, and gold. Those are some that are a little easier to recognize as metals themselves, something you can physically deal with. And typically, metals are shiny, good conductors of electricity and heat. They are flexible, workable, bendable. We can make them into different shapes, and all kinds of stuff. Metals are great. This section here, 57 to 71, 89 to 103, are actually where these guys belong down here. Kind of grab those. So this little island of misfit elements actually belongs in the periodic table, but if otherwise make it very long, so we kind of usually chop it out here. These guys are also metals. Right? These guys just would stretch out the periodic table essentially going this way and this way. Everything would kind of shut over, so you'd have a really long section, and then you bump up a little bit, and then you bump up again. You can actually find versions of the periodic table that look like that online, but this just makes it easier for us. You guys are also metals down here. Okay. Now, if something is not a metal, we call it a non-metal. Very clever. And that contains kind of the other side of the periodic table. So we have the metals over on the left, kind of them here. The top right, we have the non-metals. So things like helium and neon and argon and krypton, a lot of our gases, as well as some other materials you have inside your body, like carbon and nitrogen and oxygen, fluorine, the things that make it up. Sulfur, these guys are also non-metals. Everything I'm kind of tracing over here in green are our non-metals. We also typically call hydrogen a non-metal as well. Now, the jury's still out on hydrogen. We haven't been able to solidify it to be able to tell if it acts like a metal or acts like a non-metal. So for now, we're going to call it a non-metal, just because it kind of makes more sense, along with the other gases in the periodic table. Most of our metals are solids. A good chunk of our non-metals are gases. We also have a few potable solids over here. There are not many elements that are found as a liquid just at room temperature. Mercury is a metal that does that, and bromine is a non-metal that is a liquid at room temperature. But a lot of stuff we deal with as pure element is going to be a solid with a few gases and very few liquids in between. Now, we also have this sort of boundary between metals, our shiny conductive stuff, and our non-metals, the stuff that isn't that dull, brittle, not very flexible, poor bad conductors. in between these guys have a little bit of both. These guys are the metalloids, and they're kind of on this little stair step here, up and down this. Depending on where you look, you might have an extra element or one less that's kind of included in this list of metalloids. But these guys have a little bit of metal characteristics, a little bit of non-metals. We can't really call them just one or the other. So boron, silicon, germanium, arsenic, antimony, and tellurium kind of ride that line. So we give them a different classification. We don't call them a metal or a non-metal. We give them their own thing. So for example, silicon, like metals, can conduct electricity pretty well. It's also pretty shiny, but it's very brittle. It doesn't really flex very well. So a little bit of both. So we call it something different. We call it metalloid. All right. So these guys, for our purpose of class, silicon, germanium, arsenic, antimony, and tellurium are going to be our only metalloids on the periodic table. They're kind of far and few. Okay. So that is how we separate out metals, nonmetals, and metalloids on the periodic table. We can also dig in a little bit farther. We have specific names for the columns on the periodic table. Columns going up and down. So like we had our one valence electron stuff in the first column. All this stuff, this column going up and down, is also called a group. All right, and it's also called a family. So you might notice down here, group, 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 group. We call these columns groups, right? Or you can call them families because they have similar chemical properties, and they get those similar chemical properties from having the same number of valence electrons. So hydrogen and lithium and sodium and potassium and rubidium, all these guys act pretty similarly in ways that they react and how they bond because of that one valence electron. So we put them together on the periodic table in the same group, in the same family, in the same column. So we get this sort of odd sort of castle shape on the periodic table because of how we group elements. Right? We want to kind of have an order by atomic number, but we also want to put things that are similar together in the same column going up and down. We also have a name for the rows that go across the periodic table. Instead of just calling them rows, we also will call them periods, which is why we call it the periodic table. All right? So our periods go left to right across. So potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton, all these guys are in the same row in the same period. We just number them going top to bottom, so they would be in the fourth period of the periodic table. Now, a period goes all the way across, no matter if there's a gap or not. So, the fourth period and below is easy. Fourth period, fifth period, sixth period, seventh period. But up here, we only have hydrogen and helium in the first period. That's okay. You still go all the way across. Hydrogen and helium are still in the first period together. Right? Lithium and beryllium and boron and carbon, nitrogen, oxygen, fluorine, and neon are on the second period. And sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon are on the third period. Okay? So we've got sections of columns we call group or families. We have sections of rows we call periods. And that helps us kind of narrow down where an element is. So you might look at a set of elements that are in the first column. So you might say kind of the first group or the first family. Or you might say you're looking at elements in the fifth row, so fifth period of the periodic table. You're looking at these guys here. So it's just another way we can kind of narrow down where an element is at. Finally, for some of these groups, for some of these families, for some of these columns, we have specific names. So our first column, everything with one valence electron, is called the alkali metals group. Right? ALKALI metals group. The second column is called the alkaline, ALKALINE, earth metals group. So earth like the planet. And that goes all the way up through here. All right, so these two sound pretty similar. Whenever we do tasks on this stuff for assignments. We'll always have a periodic table that has this stuff marked available to you. So you don't have to try and memorize these. You just got to be able to recognize and pick stuff out. Right? Alkaline metals up through here. Alkaline earth metals in the second column. Everything with 2 valence electrons. We don't have specific names for groups 3 through 12, but we do call this section of elements something. Instead of going through this whole thing, we call this the transition metals, since our lanthanides and actinides down here are also supposed to be in this section. They are also part of the transition metals. Okay, so all these guys from column 3 to column 12, here to here, are called the transition metals. All right, and then on the other side of that sort of value period, we go back to having specific names. So column 13 with 3 valence electrons is called the boron group, because boron heads at the top. We didn't have a nice fancy name for it, or at least we used one anymore. Just straight to the point. Carbon at the top of the carbon group, everything with 4 valence electrons. Nitrogen at the top of the nitrogen group, everything with 5 valence electrons. Oxygen is at the top of the oxygen group, everything with 6 valence electrons. Fluorine, we don't call this one the fluorine group. Go back to having weird sciencey names for the last 2 columns, kind of like we did for the first 2 columns. So we don't call this 17th column with 7 valence electrons, the fluorine group. We call this the halogens. It's spelled Halogens. It's kind of hard to read there. Halogens. So it kind of looks like halogens group. And then this last column here also has its own name. Stuff with mostly 8 valence electrons, except helium has 2. These guys, all of them up through helium, are called noble gases group. They're like the royalty of the periodic table. They're fine on them. They don't usually bond. They don't usually react, which is why I kind of give them that name, the nobility of the periodic table. Now, also, this is the reason why helium is stuck over here with all these other valence electron elements, instead of being over in the second column with the 2 valence electron elements like it kind of should. So helium acts more like neon, argon, and krypton chemical-wise compared to beryllium and magnesium and cam. So we keep it over with its family, with a group of elements that acts more like it. So its number of valence electrons doesn't match up, but other than that, the chemical similarities are there. Okay, so in assignment 4, you're going to be looking at whether an element is a metal, non-metal, or metalloid. You'll be picking out which element you're dealing with based on the group or the period an element in, or other information like what your atomic number is, your number of protons, your total number of electrons, things like that.